goal is to classify some quadrilaterals. First, some review from yesterday. So we've learned that whenever we have the exterior angles of any polygon, they always sum up to 360. So for this one up here, I can set up an equation. 45 plus 30 plus 63 plus 51 plus 4x plus 5x. So all those exterior angles should sum up to be 360 degrees. So if I combine my like terms, 45 plus 30, 63, 189 plus 9x equals 360. Subtract the 189 from each side. So this gives me 9x equals 171. So x divided by 9x is going to equal 19. Okay. What is a quadrilateral? Well, that's what we're classifying today. And basically, it is any four-sided shape. Okay. So all the four-sided shapes, no matter how many or what kind of angles they have, what kind of size they have, any four-sided shape is quadrilateral. However, there's some specific kinds of quadrilaterals, which is what you did your definition sheet on. So square, rhombus, trapezoid, all of those are specific kinds of quadrilaterals. So make sure that you got the right definitions on your definition sheets. Here we go. Okay. So we can classify these quadrilaterals based on their definitions. So for example, this is like so true or false, a rectangle and a square. Well, let's think about this for a second. The definition of a rectangle is that it has four right angles. The definition of a square is that it has four right angles and it has four congruent sides. So a rectangle, any rectangle, is not going to always be a square because not every rectangle has those four congruent sides. So this one's false. However, a square has four right angles and four congruent sides, and a rectangle just has to have the four right angles. So that means that any square that you put out there is going to have to satisfy the definition of a rectangle because a rectangle has those four right angles. So this is true. Okay, because the square satisfies the definition of a rectangle. So that means you're going to think of this as a picture. I'm going to draw this bigger circle and a circle inside of here. And I call this bigger circle rectangles. The smaller one in here, the squares. The way to read this, all squares are going to be rectangles, but not all rectangles are necessarily squares. Okay, so all the squares are included in the rectangles, but not necessarily rectangles. So, true or false? A rhombus is a square. Let's think about the definition of a rhombus: four congruent sides. Definition of a square: four congruent sides and four congruent angles. So the rhombus, not every rhombus has to have those four right angles. So rhombus, not necessarily going to satisfy the definition of a square. However, the square, four right angles and four congruent sides. Rhombus just has to have four congruent sides. So the square satisfies the definition of a rhombus because it has those four congruent sides. That is true. So basically, all rhombi are not squares. All squares, though, are rhombi. So now let's draw this as a picture. What's going to go in this larger one? What's going to go in the smaller one? Well, if I think about it this way, let's say I wrote rhombus in the smaller one and I put squares in the top and then the bigger one. That would mean that I'm saying that all rhombi are squares, which is not true. But the opposite is true. All squares are rhombi. Put it all together. So think of it this way. So a rectangle we know has four congruent angles. A rhombus we know has four congruent sides. A square has four congruent sides and four congruent angles. So look at this. So basically, a square has borrowed from the rectangle and it has borrowed from the rhombus. Together. So basically, the rectangle and the rhombus got together and had a baby, and it was a square. So, rectangles and rhombus. So So the rectangle contributes its four right angles, the rhombus contributes its four congruent sides, and together they make a square. So that is just putting together those three terms. Let's expand now and add in the parallelogram, the trapezoid, and the isosceles trapezoid. So let's try and fit all of these together. Well, if we start thinking about it, let's see here. Is a trapezoid a parallelogram? Well, the definition of a trapezoid was exactly one pair of parallel sides. The definition of a parallelogram was exactly two pairs of parallel sides. So a trapezoid is not going to be a parallelogram. And unfortunately, vice versa is true either. I can't have a parallelogram that's a trapezoid. So between these two squares or circles, at least we know there's no overlap at all. There's nothing shared between the two of them. An isosceles trapezoid, isosceles trapezoid is not a parallelogram. But all isosceles trapezoids are going to be trapezoids because basically the definition is a trapezoid with the non-parallel sides that are congruent. So I can take this and I'm going to move it over on top of here to show that all isosceles trapezoids are also trapezoids, but not all trapezoids are obviously isosceles trapezoids. So that takes care of that one. Let's think about these up here. A rectangle, rhombus, and square. They are definitely not trapezoids, okay? Because they have more than one side up or parallel to each other. In fact, they have exactly two sides parallel, which means that a rectangle, rhombus, and square are all parallelograms. So these should go inside of this one. So I'm going to have to make this one much bigger. So I'll just extend this out like this. Grab these. There. These inside of here. Now I said that the trapezoids, they can't be overlapping, so I'm going to move these off. So there it is. Right? So all the relationships work out for us. So we're basically saying a square is a rhombus, but a rhombus is not necessarily a square. A square is a rectangle, but a rectangle is not necessarily a square. A rectangle, square, and a rhombus are all parallelograms, but parallelograms are not necessarily rectangles, squares, or rhombus. An isosceles trapezoid is always a trapezoid. A trapezoid is not always an isosceles trapezoid. And there's no relationship between the parallelograms and the trapezoids. They're completely separate from each other. So this is a diagram. So at this point, take that nice sheet of paper that I gave you and make or draw this Venn diagram out on that paper. But make it pretty. Okay, so make it easy to read and very creative and nice to look at so I can clean it up. Okay, so that is the assignment.